So in my last two classes, we have discussed about polymers, definition of polymers, monomers, polymerization, homopolymer, copolymer, and also different type of classification of polymers. That is classification based on source, classification based on structure, classification based on molecular forces, and also classification on the basis of mode of reaction. So next we have discussed preparation of some addition polymers. Today we consider our last topics, that is condensation polymers, examples and preparation of condensation polymers. So first we consider condensation polymers. In my last session, we have discussed about condensation polymers. So condensation polymers are those polymers which are formed from two or more monomers having two or more bifunctional or trifunctional groups. So there are number of examples of condensation polymer. For example, say nylon 66, terylene, bakelite, etc. So during condensation of bifunctional group, or trifunctional group, some small molecules like water, HCl, ammonia, alcohol, etc. are eliminated during the reaction. So condensation polymers are those polymers which are formed from two or more monomers having two or more bifunctional groups. During reaction, some small molecules like water, HCl, ammonia, alcohol, etc. are eliminated. So next we consider preparation of some important condensation polymers. Preparation of some important condensation polymers. So in this respect, first we consider preparation of nylon 66. Preparation of nylon 66. So nylon 66 is prepared from two monomers. Number one is adipic acid. And number two is hexamethylene diamine. So this is our adipic acid. And this compound is called hexamethylene diamine. So both are bifunctional group. Adipic acid contains two COH group, that is carboxylic group, two bifunctional group. Hexamethylene diamine also contains two bifunctional group, because for condensation polymerization bifunctional group is essential. So during reaction, small molecules like water is eliminated. So in this reaction, OH of adipic acid reacts with H of hexamethylene diamine, eliminating molecule of water, because small molecules are eliminated during the reaction. So product is CH2, CO, NH, because H reacts with OH giving water. So CO and NH, H is eliminated. CH2, 6, here also H of adipic acid, hexamethylene diamine reacts with another molecule of adipic acid, again form NH-CONH. Here also CO of remains and OH of adipic acid reacts with another molecules of hexamethylene diamine. So this unit repeated again and again. So this is structure of nylon 6,6. Why it is called nylon 6,6? Because both the monomers, adipic acid which contains 6 carbon atoms and hexamethylene diamine also contains 6 carbon atoms. So it is called nylon 6,6. So what is preparation of nylon 6,6? Nylon 6,6 is prepared from adipic acid and hexamethylene diamine by condensation polymerization. And in this reaction, N molecules of adipic acid reacts with N molecules of hexamethylene diamine, eliminating N molecules of water, forming nylon 6,6. Now, uses of nylon 6,6. Nylon 6,6 is generally used in the form of bristles of brushes and also in the climbing groups. There are other uses also known for nylon 6,6. So this is our first condensation polymer, nylon 6,6. So again, condensation polymerization is possible from monomer if monomer contains bifunctional group. This one bifunctional, this one also bifunctional. So here condensation polymerization is possible. Next we consider our second compound, which is pteryline, also known as dacron. So next we consider preparation of pteryline or dacron. It is also an example of condensation polymer. So in this case, two monomers are required. One is ethylene glycol. This compound is called ethylene glycol, and it is also contained bifunctional group. And second one is terephthalic acid. So this compound is called terephthalic acid. So it is bifunctional, that is both the monomers are bifunctional. So when ethylene glycol undergo condensation polymerization with terephthalic acid, then again OH of terephthalic acid reacts with H of ethylene glycol, eliminating molecule of water. So product is CH2O, CO, though this part is repeated again and again. So this is part or unit of polymer of pteryline or dacron. So pteryline or dacron is obtained from monomer ethylene glycol and terephthalic acid. So in this reaction, condensation polymerization takes place between N molecules of ethylene glycol and also N molecules of terephthalic acid, eliminating N molecules of water, forming pteryline, which is a fiber. So this compound is largely used as fiber. So this is major uses of terephthalic acid. It is used as fiber. So this is our second compound, preparation of pteryline. Next we consider condensation polymer of third compound, which is very important and is known as bakelite. So bakelite is obtained from monomer phenol and formaldehyde. So here monomer is phenol and formaldehyde. So first of all, phenol reacts with formaldehyde either in presence of acid or base to form a compound which is called orthohydroxybenzyl alcohol and also parahydroxybenzyl alcohol. So this is first step of reaction. Orthohydroxybenzyl alcohol and this is parahydroxybenzyl alcohol. So during preparation of bakelite, condensation takes place between phenol and formaldehyde. Originally these are both are single functional group, but bifunctional group is essential for condensation polymerization. So first of all they undergo condensation and form a product which is again bifunctional. So first one is called orthohydroxybenzyl alcohol and parahydroxybenzyl alcohol. Now orthohydroxybenzyl alcohol. So this is our orthohydroxybenzyl alcohol. Undergo condensation polymerization because it is bifunctional, forming a linear polymer this chain is repeated again and again. Which is called nebolec. Now, when it undergo further condensation reaction, then we get bakelite, that is cross-linked polymer. So, in next step, orthohydroxybenzyl alcohol and also parahydroxybenzyl alcohol undergo condensation polymerization. To form our final product which is called bakelite. So next we can write structure of bakelite. So first of all, for preparation of bakelite, two monomers phenol and formaldehyde condensed either in presence of acid or base forming orthohydroxybenzyaldehyde and parahydroxybenzyaldehyde. They undergo condensation to form a linear polymer known as nebolec. Now if both of them condensed, then form a product which is known as bakelite, which is a cross-linked product. So what is difference between nebolec and bakelite? Nebolec is a linear polymer, it is a cross-linked polymer. That is, it is thermoplastic, it is thermosetting plastic. So finally we get structure of bakelite. Now what is structure of bakelite? So in bakelite molecule, when orthohydroxybenzyl alcohol and parahydroxybenzyl alcohol condensed, then we get structure like this. So this is structure of bakelite, which is a cross-linked polymer formed from condensation polymerization of orthohydroxy benzyl alcohol and para-hydroxy benzyl alcohol. So if we sum up preparation of bakelite, so first of all, phenol reacts with formaldehyde in presence of acid or base to form two compounds. One is orthohydroxy benzyl alcohol, other is para-hydroxy benzyl alcohol. Now, orthohydroxy benzyl alcohol, when react with each other, they form linear polymer known as nebolec. But when orthohydroxy benzyl alcohol reacts with n molecules of para-hydroxy benzyl alcohol in the form of condensation polymerization, then we get cross-linked polymer, which is known as bakelite. So this is all about preparation of three condensation polymer. One is nylon 66, second one is pteryline, and third one is bakelite. So finally we consider our last compound, which is Bunay's rubber. So next we consider preparation of Bunay's rubber. Bunay's rubber is known as butadiene styrene rubber. So what is Bunay's? Bu stands for butadiene, S stands for styrene. A reaction takes place in presence of natrium or sodium, so it is called Bunay's rubber. So for preparation of Bunay's rubber, two compounds are required. One is 1,3-butadiene and other is styrene. So this is 1,3-butadiene, or simply called butadiene. And second compound is styrene. So this is structure of styrene. So butadiene reacts with styrene to form our product, which is known as Bunay's rubber. So in this reaction, this bond migrate in this position, this one migrate in this position, and this one migrate in this position. So final reaction is CH2, single bond CH, double bond CH, single bond CH2, single bond CH, single bond CH2. So this is structure of Bunay's rubber, which is a synthetic rubber and which is also an example of elastomer. So this is all about preparation of nylon 66, pteryline, bakelite, and finally Bunay's rubber. So next we consider some questions. So first of all, First of all, all questions are available in your PDF. So first question is, so number 1 is, so this is missing. So this polymer is also known as terylene or also known as dacron. So monomer of these two compound is this is number 1 is ethylene glycol or simply glycol, and other is terephthalic acid. And one important use, it is used as fibers. Second one, so it is also polymer. So if we use PDF, then you can easily answer this question. So this is for you. Number 1, adipic acid and hexamethylene diamine. So what is name of this polymer and what is uses of this polymer? So this polymer is called nylon 66. Also available in PDF, and this is used as clamping ropes and also bristles of brushes. Next one, so monomer is phenol and formaldehyde, and polymer is bakelite, and it is used for making switch and plugs. Number 5, this one also available in your PDF. So if you go through PDF, then you can answer all these questions. So other question, what are thermoplastics? Give one example, also available. Name one thermosetting and one thermoplastic. Thermosetting plastic bakelite, thermoplastic PVC. Name a synthetic polymer which is an ester. So terylene is a synthetic polymer which is an ester. Name a polymer which is used for making non-stick utensils. So Teflon is a polymer. Question number 6. What is the difference between elastomers and fibers? Available in the PDF. What is the difference between copolymer and homopolymer? Copolymer, which is formed from 2 or more monomers. Homopolymer, which is obtained from single monomers. Question number 8. Write the monomers and chemical equation for the preparation of Bunay's rubber, already discussed. Question number 9. Write chemical equation for the preparation of Teflon, already available in the PDF. Number 10. What is the monomer of terylene? Glycol and terephthalic acid. What are the monomers of bakelite, phenol and formaldehyde? Give an example of elastomers, say Bunai-S rubber, Bunai-N rubber, etc. What is vulcanization of rubber? What are the advantages available in the PDF? Write two difference between addition and condensation. Addition polymer contains unsaturation, condensation polymer contains bifunctional group. Number 15. What are copolymers? Available in the PDF. What are elastomers? Also available in the PDF. And finally, question number 16. Write the names and structure of monomers of the following polymers. Bunai-S rubber monomer is butadiene and styrene. Neoprene polymer, where monomer is chloroprene. So this is monomer of neoprene. So this is monomer of chloroprene. Neoprene monomer is chloroprene. And nylon 6 is already discussed. Monomer is adipic acid and hexamethylene diamine. So this is all about our unit 15 polymers. Okay, thank you.